Okay, welcome back to Unit 2, Lesson 3 for our geometry section. We are talking about going into our Pythagorean theorem. Here we are continuing with our lesson. Doing a small recap, we ended up talking about looking at the Pythagorean theorem, reflecting on our parts, looking at the parts of our Pythagorean theorem relating to our right triangle, knowing that our legs are labeled our A and B, knowing that our hypotenuse is always going to be our C, and our formula is going to be A squared plus B squared equals C squared. Remember that you're going to be using your formula sheet while you're doing your homework, and you're going to be given this formula sheet on your test. So you don't have to bring it to the test, but your instructor will have it there for you, right? So we'll be reflecting on that as we go along today. So here we are moving to page 36. Okay, this first part here talking about Pythagorean triples. And we're not going to linger too much on this. This is just information talking about some patterns that you may see. Pythagoras, when he was creating or looking at the Pythagorean theorem, he created or found some patterns that he discovered. We call those Pythagorean triples. Our most famous one is this first one here, 3, 4, 5. What is it saying? It's saying that relating to our formula, A squared plus B squared equals C squared. 3 squared plus 4 squared equals 5 squared. When you see one leg is 3, one leg is 4, then automatically you'll know that the hypotenuse is 5. So as you go along, you'll see that these are some patterns, and they are generated. We will not ask you to generate these patterns. We will not ask you to memorize these patterns. If you know how to use the formula, you won't have to worry about these things. But if you want to become familiar with some of these patterns, at least the first one, which is our famous one, then that is fine. Okay, we're going to move on to number 4. Use the Pythagorean theorem to find the length of the missing side. Here they want us to write our answer in 3 different ways. The exact answer, simplified. For us, this is going to mean that they want us to write our answer in a simplified radical. Okay, so leave the radical in your answer. If it applies. Now, if it's perfect, then you don't have to worry about it. But if it's not, then you're going to simplify the radical. You may have that in there, leave it. Then they want us to approximate the answer. Approximate means put that radical in your calculator, press enter, and get the decimal number. So just like it did before in our previous lesson, it means everything that comes out of your calculator, that decimal number, that's your approximate answer. So everything that comes out of your calculator. And then they want us to approximate our answer to 3 decimal places. So after we get that big long decimal number, we're going to approximate it to 3 decimal places. Okay, let's go. Here they give us a picture of a right triangle. We have a leg is 3, our other leg is 5. They want us to find the longest side, which we know is C, our hypotenuse. Here's our formula. A squared plus B squared equals C squared. Again, if you don't remember, it's fine. You're going to have your formula sheet, and down at the bottom, here's your right triangle and your formula right here. Remember, this is not talking about the area of a triangle, and that is a different formula. Okay? We're plugging it in. Now remember, your sides can be anything. If you want 3 to be A, or you want 5 to be 8, it's up to you. All we need to know is that our X is always going to be our C. So we have 3 squared plus 5 squared equals X squared. And then we're going to go ahead and work that out. 3 squared gives us 9. 5 squared is 25. Okay. Now we are not saying 3 times 2 is 6 or 5 times 2 is 10. Okay. We are raising these numbers to the second power. So watch that. And then we have X squared. Then add these two numbers together, and 25 plus 9 gives us 34. Again, you're going to be working a lot of this in your calculator, that's fine. Now remember, we're trying to solve for X, and right now we have X squared. So when we are solving for X, we need to take the square root. Okay. Oops. I jumped the gun. Okay. Take the square root of both sides of your equal sign. If you remember, we call this a square root property. Okay. Now we'll take the square root of both sides. We are going to now see if we can break down our square root of 34. Always check to see if it's perfect. Put it in your calculator. Your square root button is usually in a second function, or if you have a graphing calculator, it's in your math function, your math button. Okay, but usually most calculators it's in the second function. Sometimes you have a model where it's actually on a face button, but you should be familiar with our square root button. You'll see that it's not perfect. When they want you to simplify it, we need to know what that means. And that means that we are trying to, it's not perfect, we need to see if there's some factors of 34 that have a perfect square root in it. So that brings up our knowledge of our perfect square roots. So knowing what those are and seeing if they fall within the factors of 34. Now you can use a factor tree for this if you're familiar with that, or just simply be familiar with the first 5. I recommend you know the first 5 perfect square roots so that you can see if they go into your number. Okay, so our first perfect root is 1. 1 is perfect all the way around, so that doesn't count. So our first perfect square root is 4. Why? Because 2 times 2 is 4. Can 4 go into 34 evenly? You'll put that in your calculator and see if it gives you an even number. You'll see that it does not. Your next perfect root, go right up the list, would be 9. Why? Because 3 times 3 is 9. Can 9 go into 34? The answer would be no. Then check the next one, and check it until you feel confident that there is nothing there, or that you did find something. And then you can go up to the next one. 4 times 4 is 16. Is 16 a factor of 34? The answer would be no. So once we check it, we'll see that the square root of 34 cannot be broken down into or simplified any more than it is. So we have the square root of 34 equals X. This is our exact answer. Okay, so the square root of 34. Okay, now we're putting it in our calculator, right? We'll see, checking it, you'll get that nice little decimal coming out. The square root of 34 is this big number here, 5.830951895. All right, this is our approximated answer. All right, so all of that. But now they want us to round our answer to 3 decimal places. So rounding it to 3 decimal places. So remember, we're looking at our 3rd decimal place is right here with this 0. Looking at the number right behind it. If it's 5 or higher, we have to round up. So we'll get 5.831. So this is to 3 decimal places. So remember, make sure we know how to round. Make sure you're following the directions of your homework. Okay, let's go to the next one. Here's our next triangle. Okay, and here we're solving for one of our legs. Now, in the homework, you'll notice that when you click in your box to enter your answer, a yellow arrow usually pops off to the right. That will open up, when you click on that arrow, will open up a formatting box. That's how you're going to enter in your radicals or your roots. So use that. Some of you may know the syntax already and you can type it in yourself, and that's fine. Make sure you click the preview button all the time and make sure your answer appears the way you want it to appear. You don't want to get it wrong because you have a syntax error, because you put something in the wrong way. So to make sure that you actually enter your information correctly, use the formatting arrow. Okay? All of your symbols are there. Your root signs, your pi signs, everything's there as needed for that particular problem. Okay? All right, let's move forward with our next problem. Here we are. It's always good to write your formula before you use it. This helps to solidify it in your mind. Okay? Plus b squared equals c squared. Now we're plugging in. We see that we have our hypotenuse here. We have an a here, but we don't have the b. So we have 5 squared plus x squared equals 7 squared. Now that we've plugged it in, you might want to pause here. Go ahead and see if you can work it out, and then come back and we'll check our answer. All right, so here we are working it out now. Remember, we first have to solve for x first. So here we are. We have 5 squared is 25 plus x squared equals 7 squared is 49. All right. Now we got to get x squared by itself. So we need to subtract 25 from both sides. So we get x squared equals, subtracting 25, you should get, I got that too. All right, now it's ready to take the square root. Remember, don't take the square root until you get that x squared by itself. So then you have x equals the square root of 24. Is it perfect? Again, check it in your calculator, and we'll see that 24 is not perfect, but we can find some factors in 24 that does have a perfect square root. So here's 24. Now I'm going to write some factors for it. Okay, so the factors of 24, we have 1 times 24. We have 2 times what? It's always good to write it out. And that way you can see what's happening. 2 times 12. This is kind of like writing out your factor tree, right? But if you write out all the factors, then you can see if it has a perfect root in it. Okay, and what's our next set of factors? Does 3 go into there? All right, so if it helps, just write all your factors. And that way, if you can't, don't want to focus on just the roots, that's fine. But it's always good and it saves time if you know what the roots are. So we have 3 times 8. Nope, not a perfect root. What about 4? 4 times 6. Oh, looks like we're almost there. We think we got it. Any other factors? 5 doesn't go in there. And 6 we start repeating. So when we look at our factors, I see right here 4 is a perfect square. All right? Because 2 times 2 is 4. So right here, that's my set of factors that have a perfect square root in it. So I'm going to break that 24 up underneath my radical as 4 times 6. I can't use these other factors because they don't have a perfect square root in it. Okay? All right, so now I'm going to simplify my radical. So we have x equals, the square root of 4 is 2. And then we're left with the square root of 6. So this, my exact answer. So 2 square roots of 6. All right, so now we can either put the square root of 24 in our calculator to find our decimal, our exact approximation of the number, or we can put in 2 square roots of 6. Either way, right? When we put it in, we're going to get 4 point. Big number coming out now. 8, 9, 8. Now you're verifying. Did you get this? 7, 9. All right. 4, 8, 6. Okay. Everybody should have gotten something like that. And then when we round it to 3 decimal places, remember, this is my 3rd place right there. When we round it up, because that 9 is behind it, we get 4.899. All right, how do we feel about it? Not too bad, right? I think we just have to remember about our simplifying our radicals needed. And some of us might have a calculator that already does it. If you do, and you're trying to find your decimal number, you have to use your toggle button, which is probably found right above your equal sign or your enter sign. Okay? Use that double arrow and it'll change it to your decimal for you. All right? Let's move forward. Now, most Pythagorean theorem problems usually come as word problems. Sometimes they'll give you the picture representation of the word problem. So here they didn't give us a picture, but if you need a picture, you draw it. Let's read the problem. A 12-foot ladder is leaned against a house so that the base is 5 feet from the side of the house. How far up the side of the house will the ladder reach? Again, they want us to give the simplified exact answer, approximate answer, and now they want us to approximate your answer to 2 decimal places. All right, so we have a ladder leaning up against the house. So if it makes you feel better, draw a picture. We need a house. So here's a house. We need a window. Yeah, that makes us feel better. And we need a door. Okay, there's the house, right? And we have a ladder leaning up against the side of it. There's my ladder. So it says a 12-foot ladder. So this is 12 feet. Is leaned against the house so that the base is 5 feet from the side of the house. So here's the side of the house, the bottom of the ladder, and this is 5 feet. Okay? Then the question is, how far up the side of the house will the ladder reach? So they want to know, what's that? Okay? All right, so there's our picture indicating what's going on. All right. So now let's work it out. Go ahead, pause the video here, see if you can work it out. We'll come back and check it out. All right, so we have our a squared plus b squared equals c squared. Here we have our side missing, so I'm going to have x squared plus 5 squared equals 12 squared. Okay, then we're going to go ahead and do our work. So we have x squared plus 25 equals 144. Go ahead and subtract, right? Subtracting it over. Then we get x squared equals 119. Take the square root. And we have x equals the square root of 119. And after we check it in our calculator, we see that there's no factors of 119 that we can break down or simplify our radical. So our exact answer, square root of 119. But now watch it. Now they gave us dimensions in this one, so we need to put those feet. Okay. All right. So now we need the approximate answer. Putting that in our calculator, we come out with our decimal starting with 10. And we have 10.908712211. So 1. Okay, then feet. Now this time we're approximating to 2 decimal places, not 3, but 2. And here's my second place right there. So when we round, we get 10.91 feet. All right. So there we have our Pythagorean theorem all worked out. Okay. So working things out, ready to go. Making sure we're watching, making sure we're paying attention to what's being asked, how they want you to enter your answer. They may not ask you for all 3 representations. They may, okay, but they might ask you just for 1. But we need to know the difference between the 3 for sure. Right? Okay. Let's take a quick peek here. Looking at area perimeter. Now, here's this next one, number 6. They want us to find the perimeter and area of this triangle. It just so happens to be a right triangle. Just because they give you a right triangle doesn't mean that you have to use the Pythagorean theorem all the time. But there may be times where you have to layer what you're doing. So you may have to layer the formulas that you're using or the processes. So watch out what's happening. When they want us to find the perimeter here, there you see perimeter simply means that we want to add up the sides. So we have this side, we have this side, but we don't have this side, okay? So always evaluate what they give you. And if you're missing some pieces, then you got to find them. So that's your first goal, is to find all missing pieces. So they want us to find a perimeter. Perimeter means to add all the sides up. Then they want us to find the area. Area actually has a formula. Here we are going to our formula sheet. We're looking for the area of a triangle. It's right here. Area equals 1/2 base times the height. And remember, they're going to label your picture for you so you can remember what the height is and what the base is, right? So area equals 1/2 base times height. 1/2 base times height. So now let's get that missing piece. Just so happens it's the right triangle. We do need the Pythagorean theorem here to find it. Now, if you remember about that triple that we talked about at the very beginning, that famous one, you might already know what this side is. But don't worry, we got our formula. So first, find all missing parts. Here we're going to find our x. So we have a squared plus b squared equals c squared. So we have 3 squared plus 4 squared equals x squared. That gives us 9 plus 16 equals x squared. 9 plus 16 gives us 25. Taking the square root of both sides, the square root of 25 is 5. So we see that x equals 5. All right, so now x equals 5. We have all the parts of our triangle. We can find our perimeter. So now we see that P equals 3 plus 4 plus 5. And that gives us, yes, just that simple, 9, 10, 11, 12. 12, and don't forget your dimensions, feet. Okay? Now let's find the area, third part. So area equals 1/2 base times height. Remember what we said the base and the height was, so 1/2. Our base is 4. Our height here is 3. Now you can put this all in your calculator, but we really don't even need that here. If you have that fraction is freaking you out, go ahead and simplify it right here. We see that clearly 2 goes into 4 2 times, and then just multiply 2 times 3 gives you 6. You have 6 feet. But now remember, we're talking about area. So remember that area, when you're talking about the inside of something, you have to take action on your dimensions. So we have feet squared. So we have 6 feet squared. So remember, area is always squared units. Okay, always squared units. All right, wasn't too bad, right? Let's check out our next one. I think we can squeeze it in. Here we have our friend, the rectangle. Again, they want us to find the perimeter and the area. So we know the perimeter, we're going to add up our sides. But let's get the area. Again, going to our formula. Remember, you're going to have this sheet with you while you're doing your homework. Here's our rectangle. The perimeter has a formula, but if you want to keep it simple, you know you're just going to add up the 4 sides. The area is length times width, right? So here we are. So we have area equals length times width. Now, make sure you pay attention to what they give you. Here where they give us 9 feet, and then they give us 1 yard. You notice the dimensions are different. That's a no-no. We got to pay attention to this now. You can't combine apples and oranges. So something's got to change. Here we have to convert. Okay? So note. Different dimensions. Can you read that? Sorry, right? So convert something. Now, follow the problem. They might ask you to solve for a price for something. They may ask you to actually guide you to determine which one you actually change, okay? Depending on their question. Here we can go from feet to yards or yards to feet. Here we're okay, but it looks like it might be pretty quick to go from yards to feet. What do you think, right? Because how many feet are in a yard? Right, there's 3, right? So we can change this 1 yard to 3 feet. And that was a really quick conversion there. So now everything is in feet. So now we can go ahead and proceed with everything. So our perimeter, we have, you're using the formula, 2L plus 2W, or just adding up everything. Then we have 9 plus 9 plus 3 plus 3. That's old school. Then you can add all of that up and get your answer, or use your formula and still get your answer. Either way is okay, all right? Whatever feels comfortable to you. So that's 10, that's 20, looks like 24. 24 what? Feet. Now our area, length times width. We have our length, we have our width. So our length is 9. Our width is 3. Okay? So now we have 9 times 3, 27. But remember, area always squared feet. So 27 feet squared. Is everybody all right? Okay. All right. So important, so very important to pay attention to the dimensions, to make sure that they are all the same dimension before you get started. Otherwise, your answer will surely come out to be what we call wrong. We don't want that. Okay, so watching that. All right, let's try this next one. All right, we look at the shape here. You remember this is called a parallelogram. We know because these 2 sides are parallel to each other. The top and bottom are parallel to each other. So this is parallelogram. So if this side is 2 meters, then this is 2 meters. If this is 2.5 meters, then this is 2.5 meters. Now, we got all the sides labeled. Let's get the area. Go into our formula sheet, looking for that shape, and it's right here. All right, the area for our parallelogram is base times height. Here's our height and the base of our shape. So base times height. All right, we're ready to find it. So we have P equals and A equals. So again, perimeter, just adding up our sides. So we have 2 plus 2 plus 2.5 plus 2.5. So what's that? 2, 4, 6, 8, 9, right? So 9 meters. Our area, base times height. Remember, our base is the bottom here, 2.5. Okay. And then the height, remember, is that thing right down the middle, is 1.8. Now, when we multiply, what do we get? 4.5. But 4.5, that's right, meters squared. Good. Okay. Looks good. So, getting familiar with that formula sheet, it's good. All right. Make sure you have it with you. Again, you're going to have it on the test with you. All right, one more. Let's see if we can squeeze that in. I don't know if we'll get to the other one, but let's see if we can get through this page. All right, here we have this shape here. You may remember it. This is called a trapezoid. Now, I remember it because it looks like it's trapping you in. You got 2 parallel sides here on the top and the bottom, but then it starts closing in on you on the side. So it's like trapping you in. I know, it's kind of weird. But you know, hey, you got to do whatever makes you, you'll be able to, get it right in your own mind. Okay? So there's our trapezoid. Let's go and find our formulas now. So looking for that shape. Okay, here's our trapezoid. And here's the area. Area is 1/2, h is our height, times a plus b. So our a represents our bottom here, and b is our top. But notice when we put it in here, we're just adding those numbers together. So it doesn't matter which one you put first or second in there, you're still adding them together. It's okay. So 1/2 h times a plus b. So area equals 1/2 h times a plus b. Okay. So now let's go ahead and work it. Now you notice they didn't give us any dimensions here. So we just use the word units. When they don't give us any dimensions, we use the word units to help us remember what we need to take action on. So here's our perimeter and our area. Okay. All right, so our perimeter. So our perimeter, we're adding all that goodness up. So 7 plus 8, go right on around, 10 plus 13, and adding that up, and we should get 38. 38 units. All right. For our area, remember we have 1/2 our base, okay? Our height times a plus b. Now, if it helps, label your graph so you'll know what's happening, but we're okay. we have 1/2. Our height here is 6. And then A plus B. So A was 13. And our B is 8 up there. Okay. And then again, if that 1/2 is really throwing you off, go ahead and simplify it out. So 2 goes into 6 3 times. And then all you have to do is just add these together and then multiply it by 3. When you do that, you get 63. Okay, but we got 63 units squared, right? So units squared. Or you can write out squared units. It's okay. All right, so we have our trapezoid down. Let's pick up this circle. And I think that'll be it for number 6. So here's our circle. Now, circle doesn't have a perimeter, but it's called not called the perimeter, but it's called a circumference. Okay, so let's go to the formula sheet and get our formulas. Here's our circle. The area is pi r squared. And then the circumference has 2 formulas. It has pi d, or you can use 2 pi r. Now remember, your diameter is from one end of your circle to the other, going through the center, and your radius is from the center to an edge. All right, so again, it's going to be labeled for you, so if you need to remember what they are. So our area or circumference equals pi d or 2 pi r, and our area equals pi r squared. Now, remember, you might have to find some pieces here first. So this is our C and our A. Now watch how they want us to write our answer. You see it says exact answers in terms of pi. This is just like our exact answer with our radical. When we want exact answer, that means leave that radical alone. Well, here it means the same thing. Exact answer in terms of pi means leave that pi sign alone. So it means the same thing. So leave pi alone. Okay? Because we know pi can be approximated, but they don't want us to approximate it yet. So when they ask you to approximate it, you'll take action on it. But if they don't, and they want you to write it in terms of pi, it's going to be in your answer. So let's check it out. All right, so for our circumference, they give us a diameter of 8. Let's just use our pi d, and we'll be done. We'll plug it in, pi, and our diameter is 8. So our circumference is 8 pi. Okay, 8 pi. And then inches. All right? And that's in terms of pi. You see, we still left it in there. Now our area requires a radius. So now we need to find our radius. So our radius equals half of our diameter. So our radius equals 4. So using our area formula now, we have pi. We're plugging in our radius of 4, but we got to square it. So now we have pi, and then 4 squared is 16, right? So now our answer is 16 pi. Always bring your whole number in front of your pi sign. It's almost like having an x. You don't say x16, you say 16x. So you say 16 pi. So here's our answer, 16 pi. But remember, inches squared. Good. So in terms of pi, means leave the pi sign in your answer. So leave it alone. All right, well, I hope this video helps get us through looking at the area and perimeter of our figures, and also help us to manipulate and use our formula sheet. Make sure you're becoming familiar with that to get ready for the test. All right, see you in the next video.